Okay, welcome back. And my name is Massimiliano Di Penta. Like Michele, I used to be a leader. And now we have another session with three exciting leaders talking about data. The first one is Gabriele Parotta. Gabriele is assistant professor at the Free University of Bozen, almost Italy. And he's going to talk about mining unstructured data.
Okay. Can you hear me? Yeah? Okay. Thank you much for the introduction. So my talk today is about the mining of unstructured data and software repositories. So first of all, let me start to define what we mean with unstructured data. Unstructured data refers to information that is not organized by following a precise structure or schema. For instance, good examples of unstructured data are mail messages that we simply write in natural language without organizing the information by following a specific template. These also apply for most type of textual documentation, as well as for multimedia contents like images, videos, or slides like this presentation, and so on. Now, why unstructured data are so important? Well, a very recent study showed that 80% of information in enterprises is embedded inside unstructured data. So this means that if you limit your view to the structured data, you are missing the vast majority of the information. And if you think to unstructured data that are available to every one of us on the internet, for example, well, there are some numbers that are simply impressive. Like, for example, this is what happens every hour on the internet. There are over 100,000 users looking for a Stack Exchange, that you know is a very popular question and answer platform. And these are all unstructured data because people are asking questions, are answering questions, and so on. And there are over 6,000 hours on new video that are uploaded on YouTube. So again, unstructured data, again, a lot of information. Now, I hope that at this point of the talk, you are convinced that we are surrounded by unstructured data, that they contain a lot of information, but where they are in software repositories, because at the end, what we are really interested in are software repositories as software engineers. Now, I will show you a very short example of the kind of knowledge that you can extract from software repositories by mining unstructured data. So nowadays, most of software projects rely on a versioning system, right, like in SVN, in order to track the changes performed over time. So we have a set of commits performed over time by developers, and each of these commits contains a lot of information, like who is the author of the change, when the change has been performed, which code files have been impacted, and so on. These are all examples of structured data. However, most of commits also contain unstructured data, like what we call the commit message or the commit note, right? That is a very short explanation in natural language of why a commit has been performed, what it changed in the system. Of course, this is what it should be at least. In this case, for example, we see that this commit fixed an issue that is identified by given ID. Now, most of the software projects do also rely on other platforms like issue trackers, where the developers discuss of new features to implement, or of bugs to be fixed, and of changes to be applied to their system. Again, we have several information for each issue, like an identifier, this is the type, this is a bug, and this is a feature, a description of what this issue is about, and so on. If you start mining the information in these repositories, you can, for example, find that this commit fixed this bug. Why? Because you find the identifier of this bug inside this commit node. So what you are doing is to extract a small piece of knowledge that is the rationale behind a specific commit, why a commit has been performed. If you do a further step ahead, and for example, you start mining the comments that are in the discussion performed by the developers while fixing this issue, you may find, for example, that this issue has been fixed, this bug has been fixed, as recommended in a Stack Overflow discussion. Why? Because you find the URL of the Stack Overflow discussion in one of the comments left by the developers. So you are extracting another piece of knowledge that is the rationale behind the specific implementation choice. So if you close the circle, what you have done is to document this change, why it has been performed, why this bug has been fixed in that way. And if your project is a mobile app, you can issue a new release, you can publish it on an app store, and you can start collect the reviews posted by the users, because you know that on the App Store, the users can post reviews describing their experience while using your app. So, for example, failures that they observed or whatever you want. And if you're smart enough, what you can do is to mine these unstructured data in order to automatically collect issues for your app, like, for example, the bugs that you need to fix, new features that you need to implement, and so on. Now, this is just a very, very small example, okay? But if you look at all the green arrows that are on the screen, well, these are all new pieces of knowledge that we extracted by mining unstructured data. So my message for this first part of the talk was to be that if you look inside software repositories for structured data, well, you have a very clean and structured view, but what you are doing is to miss the vast majority of the information that is embedded inside unstructured data. Now, how can you exploit this information? Which techniques can you exploit to mine this information? Well, I don't have time for a tutorial, of course, and this is not the goal of this talk. So let me just give you a very quick overview for the ones of you who are not familiar with structured data. A first family of techniques that you can exploit are pattern matching techniques that basically mean looking for a pattern that is a sequence of textual token inside a piece of text. So suppose that you want to identify in all commits performed by a developer in a versioning system the ones when he tried to reduce the energy consumption of an app, you can define a regular expression that matches specific messages in the commit nodes. Like, for example, reduced energy consumption, reduces battery drain, and so on. So if you find a commit message in the versioning system that contains a sentence like reduced energy consumption, then you are able to match it, you are able to identify this commit as relevant for your study, as one of the commits where the developer tried to reduce the energy consumption of his app. What is the problem of pattern matching? It is not flexible. If you find a commit like the reduced battery consumption, this is not matched by the regular expression that I defined, so I'm missing this data point, okay? If you want something a bit more powerful, but also a bit more complex, you can go for information retrieval, that are techniques used to identify in a vast document corpus the documents that are relevant for a given textual query. And they are more powerful because they do not look for exact string matching. They are able to automatically infer word relationship. For example, they are able to infer that improved and reduced have the same meaning when followed by the bgram energy consumption. And they assess the relevance of a document for a query by looking for word overlap. Of course, this is a very high-level explanation, but this is the idea. Third family of techniques that we have natural language processing techniques that are used to automatically extract the meaning from a piece of text. They are used, for example, for text normalizations, part-of-speech tagging, or sentiment analysis, so to automatically identify what is, for example, the polarity of a user review. This is a positive user review versus this is a negative user review. Now, with these techniques and much, much more, the software engineering community has investigated a very high amount of different research directions. And believe me, there are literally thousands of work that are in one way or another related to the mining of unstructured data. And of course, we do not have time to talk about them, but these are, for example, 5 research areas in which the mining of unstructured data really played a major roles in the past years. For example, we have approaches to automatically generate documentation, to automatically generate code samples that are based on the mining of unstructured data. Or we have recommender systems to recommend, for example, Stack Overflow discussions that are relevant for a given task, that again are based on the mining of unstructured data, or we can classify textual artifacts, like, for example, which user reviews are reporting bug versus which user reviews are recommending new features to implement, okay? Now, with all this work that has been done, again, thousands of papers, what can we do, what we can expect for the future? First of all, let me say that I'm going to present 2 future trends that I believe will be relevant, and this is not something that I expect 10 years from now. This is something we are starting doing now, and these are research directions that I believe are very promising for the future. The first one is related to recommender systems. So we are producing, in software engineering, very cool recommender systems. This is my very personal opinion, of course. But we are able to recommend very useful pieces of documentation, for example, to developers, very good information to software managers. And let me show you an example of these recommender systems. This is a work performed by Laura Moreno and others to automatically summarize code components. So what they do is basically to take as input a Java class, The Java class is provided to some natural language processing machinery that they developed, and the natural language processing provides as output a class summary. So instead of reading hundreds of lines of code, you just read a few lines that summarize what are the main responsibilities implemented in a class. So you get something like this. Okay, this is the kind of output that you get. Now, this is very cool, and this is very representative of the type of recommender systems of approaches to generate documentation that we are developing by mining unstructured data, and that we are developing in general in software engineering. What is the limitation of these techniques, of all these techniques, or at least the vast majority of them? Well, the problem is that their output, their recommendation, is not adaptive to the specific context in which this output, this recommendation will be used. What does it mean? Well, suppose that you have two developers. One is a very experienced developer, the other one is a novice developer. Probably they would both benefit from a summary like this, but they would benefit even more if the summary is adapted on the basis of their background, on what is their knowledge. Or suppose that you have, again, two developers that have to perform two different tasks. One has to implement a new feature in this class, the other one has to test this class. Probably they need different information in this summary. Probably the developer who has to test this class would benefit from knowing what are the methods in this class having the highest change and fault proneness. But probably this information is not relevant for the developer who has to implement a new feature in this class. So the point here is that the output of these recommender systems of this technique is very, very nice, but it's not tuned for the specific needs of the people who has to use this output. So what I believe will be a future trend, something promising for the future, is that these tools are able to adapt their output based on the user that has to exploit this output and for the specific task for which this output, like this new piece of documentation, will be used. So this is the first thing I wanted to talk about. The second one is related to the mining of multimedia contents. So if you talk about unstructured data in software engineering, well, 99% of people will directly think to textual information contained in software artifacts or in software repositories. However, unstructured data are also, by definition, multimedia contents, like images, slides, video tutorials, and so on. And you know, there was a very recent study presented at SCPC 2015, where the authors analyzed why developers share their knowledge via video tutorial uploaded on YouTube. And what they found is that the video tutorials contain a set of information that is very difficult to report in other types of documentation, like textual-based documentation. For example, suppose that you want to learn how to use an API method. If you watch a video tutorial, you are not just learning how to use the API method. You are also watching how the developer is interacting with the IDE, for example. So you are gathering more knowledge. You are gathering knowledge that is difficult to report in a textual-based documentation. Okay? The problem with the video tutorial is, however, that in general they are very, very long. So if you need to learn how to use an API, it's possible that you need to watch 3 minutes of video that, however, is embedded in a 2-hour video tutorial. Why? Because, for example, this is a university lesson, okay? And you need basically to go back and forth in this 2 hours in order to identify the 3 minutes you are interested in, because there is no index and it's difficult to query the content of a video tutorial. You do not have any support. So what we are doing is to try to understand how to mine these multimedia contents. And what we did was to develop this tool called Tube that will be presented at TICSI 2016. This is a joint work between several different universities. Let me just say that Luca Ponzanelli, who is there, is the PI from the L'Università della Svizzera Italiana in Lugano. And what CodeTube does is the following. So, again, suppose that you want to learn how to use this API method. You write a query, a textual query describing what you are looking for in video tutorials. For example, you want to learn how to pin a marker on a Google map in an Android app. So you write this query, pin a marker on a Google map, and you get some results from CodeTube. What are these results? These results are not video tutorials. These are fragments of video tutorials automatically identified by CodeTube as relevant for the query that you wrote. For example, in this case, CodeTube suggests to just watch 3 minutes of this video tutorial that is quite long, is much longer, in order to learn how to perform this task. Once you select the video fragment that you want to watch, of course, this is identified by using some heuristics. You can watch the video fragment, and you also get some recommendations about Stack Overflow discussions that are related to the video tutorial that you are watching. So the conjecture is that the video tutorial provides you some basic information, like how to use an API method, and the Stack Overflow discussions can complement this information by describing what you should do in, for example, scenarios where you get an error from this API or things like that. Now, the machinery behind CodeTube is very, very complex, and I don't have the time to explain it. Let me just say that we analyze a lot of unstructured data. We analyze the audio transcripts of the video tutorial. We analyze the text extracted from the video fragments to understand what is the fragment about, what the tutor is talking about over the whole video tutorial. And we use OCR techniques, so optical character recognition, in order to extract the text from the frames of the video tutorial. And we extract the code shown in the video tutorial, so the different snippets, by using Islam parsers. So that's it. I mean, if you want to know more about CodeTube, there is the preprint online, and you can attend, of course, Luca presentation at TIXI. If you missed something in my talk, there is much more in the paper that is related to this talk. There is a description of perils to avoid while mining unstructured data in software repositories, how to use unstructured data to perform qualitative analysis, and other suggestions for future work. So that's it, and if you have questions, I will be happy to answer.
Thank you.
Nate?
So, in very good talk, thanks.
Thank you.
And in the future work, you're talking about recommendations.
Mm-hmm.
One thing that I find concerning in other recommendation systems, not software recommendation, like Facebook, for example, it now tailors to me, and I think it's making me think what I should be thinking, right? It's starting to cut down information that I might have been interested in. And so how do you make sure that if you're making a recommendation to a senior developer, how do you avoid that pitfall? That you're choosing what they should read, and will that go down a path that you don't want to?
Yeah, I mean, can you also summarize the question for me?
Yes, basically the question is how can we make sure that the pieces of information that are recommended to someone are relevant for this specific person, right?
More so that if you start choosing them, then maybe they want something else that is not part of their historical pattern, suddenly.
Yes, okay. Well, I'm not sure that you can really solve this problem in an easy way. It really depends on the kind of recommender that you want to build, because sometimes you just want to recommend something from a very specific context. Like it could be the user reviews that are useful from your app reviews. In this case, I think it's easier. But if you wanted to recommend, for example, about pieces of knowledge that are spread on the internet, then it's very difficult to understand what is relevant for him and if this is enough for him and so on. And this is the whole point of recommender systems, I guess. But I don't really have an answer on how we can solve this in a general way, let's say. It really depends on the specific problem you want to deal with. Okay?
Thank you. So you mostly, or so it seemed, that you were mostly talking about mining unstructured yet perfect data. So data that is not damaged, data that is not incomplete, and so forth. So what is your view on mining that kind of more realistic unstructured data that we usually have in practice, something that's been broken or that contains errors, contains mistakes, contains inconsistencies and so forth. It seemed to me also unstructured, but not from your talk. So
okay, yes. So the question is about how can we deal with unstructured data that are not only unstructured, but for example incomplete or contains error. And I think this already happens when you try, for example, to mine information from Stack Overflow, question and answer forums. And I think the challenge in this case is really to define some proxies that you can measure that allows you to understand if the piece of information is good or not. For example, in Stack Overflow you have the accepted answer, right? So you can guess that in this case the information contained in this answer is correct, while you cannot make a guess probably on the other answers that are bad. If you have other specific examples of unstructured data broken that you may want to talk about, I don't know if you are referring to something else.
I have a lot of examples in mind, but basically, your answer, as far as I understood, is to identify something that's not broken, that's validated, that's kind of has some certainty, and throw away the rest.
As much as you can, yes. If you have this indication, but of course it's not always the case. I made the example of Stack Overflow that is an easy example, but in some other contexts you don't have a clear proxy from the type of information that is good and the type of information that is bad. So what you should try to do is to define some proxy in some way. This is the only thing that I can think about.
Thank you.
Question?
No? I want it. Okay, I will ask you the same question that Michele asked before to Thomas. What is software engineering specific in mining unstructured data? Because you know many techniques are already being applied to other kind of natural language sources.
Sure. Well, again, I think a bit is the context that helps. I mean, if you try to mine data that are relevant for software developers, of course, this makes it software engineering. But for example, in the case of CodeTube, since we are mining development video tutorial, we had to define some techniques that are specific for the type of video tutorials. For example, we take into account the source code that is shown on the screen. That is something you do not care about if you want to mine other types of video tutorials that are not related to software engineering.
Okay, thank you. Question for Aiko?
Have you thought of using crowdsourcing for identifying relevant snippets of code in videos? Like ask the developers to actively engage on identification of info?
No, not yet, but it's a good point. I mean, you could try to identify, I'm not sure really snippets of code, but at least what are the video tutorials that are more useful for developers. It's something that I think is doable.
I'm asking because actually there is a social platform that helps, that is around asking people to tag segments of video and share them.
Okay, manually you mean?
Yes.
Yes.
Yeah.
Mm-hmm. Okay, thank you.
Michele?
Cute slides. I have a question. So, software engineering research suffers a little bit from the been there, done that syndrome, which means today or yesterday we mined structured data, today we mine unstructured data, tomorrow we will mine videos, and we keep doing things like that, and then we do it like for 1, 2, 3 years, and then the field is raised down, okay, and then we go to the next field. What is the next field?
Well, one, I think it's really multimedia content that is anyway still related to unstructured data. And then I think all the type of information that is crowd-based in some way would really be the future, would be the things that we will mine for the next years.
What are your thoughts on sarcasm in unstructured data? Have you ever thought of how to work with that? Especially with reviews, people would say, "Oh, I love this thing," but actually, or developers saying this is really good code, but it's not really.
Yeah, I understand. At least in the context of this last work that I did, like the mining of video tutorial, no, we did not take this into consideration. When mining unstructured data, like from user reviews, I think there are works that do this. There is a work by Panicella and others that I think defines specific detection rules for this kind of patterns in the user reviews. So these are based on natural language processing and on pattern matching techniques. So there are some techniques, and yeah, I think in one way or another we can deal with it, and also by using some machine learning mechanism to clearly distinguish what are the characteristics of this kind of, for example, user reviews with respect to the others. So I think we can deal with it. It's just noise that we need to deal with.
Is that a serious question, Ahmed? Because I couldn't tell.
Okay, maybe one last question from the back.
My question is about the generating summarization for Java classes. And I want to know when we generating the summarization, do we need to use some other materials? For example, we need to understand the usage of each API. So we need to analyze the Java official document of each API, or we must use the information from the website, such as the Stack Overflow.
Well, actually, there are works that are able to automatically generate pieces of documentation by mining information on Stack Overflow. If I'm not wrong, Max, you did something to generate comments from Stack Overflow discussions. So there are already some work that do not only exploit the information that is inside the source code, but that also go outside to collect other kind of information. So you may have a look to this kind of work.
Okay, thank you.
Yeah.
Okay. Thanks, Gabriele, again.
Thank you.